Next up, we're going to talk about direct variation. And all direct variation is it's a very specific type of a linear relationship. Specific type of linear relationship. Now, a lot of people think a specific type of linear relationship is going to be more difficult than a linear. It's actually a more basic type of a linear relationship. So the specific type of linear function that we're looking for, all it means is that when x increases, y increases by the same factor. So when x increases, y also increases by the same factor. And that could also be decreases. It doesn't have to be a positive relationship. It could be negative as well. But we'll say when x increases or when x changes, y is also changing by the same factor. Another way of saying that is that y and x always have the same ratio. And ratio being y over x. So that y over x value, regardless of what y and x are, whatever numbers they are, when you simplify that ratio, it's always going to be the same. All right, when we do direct variation, we're going to look at direct variation with equations, with tables, with graphs, with word problems, and they're all going to have kind of this special pattern to them. So we'll break it down into each type of category, starting first with equations. To have that constant ratio, as x increases, y increases by the same factor, for that to happen in a direct, and for it to be direct variation, there's a couple of specific things that have to happen. And the first one is this one's going to come up in in the equations, tables, graphs, everything. The first thing that has to happen is that the y-intercept has to be 0. The y-intercept has to be 0. What that means is it's going to go through the origin. Okay? On a graph, it'll go through the origin. But in an equation, since we have that y equals mx plus b form, the slope-intercept form for an equation, what that means is that b has to be 0. Because b represents the y-intercept. So your b value has to be 0, which means you don't really have that slope-intercept form because you wouldn't put plus 0 at the end. So instead we do kind of a different form of the equation. It's still basically y equals mx plus b, but instead we write it differently with a different variable. Okay, instead of m, we use y equals kx. So you still have the x, you still have the y, we don't have the b because the b has to be 0, and we do have this k value. So the k value has a specific name. The k value is called the constant of variation. This is what that factor is going to be, that same factor, that same ratio. That's going to be your k value. And again, it's called the constant of variation. All right, so our equation is actually a little easier. Our equation is just y equals kx. K is the constant of variation, x is the input, y is the output. So recognizing a direct variation equation is easy. If it has a y-intercept, it's not direct variation. And your slope, which is still your slope, it still works as slope, still rise over run, change in y over change in x. Your slope is now also called your constant of variation. Okay, that's going to be the factor that changes your y value. So let's look at some examples of equations. So in these examples, determine if the following equations show direct variation or not. If yes, give the constant of variation, the k value. If no, show y. Well, these are easy. All you're looking for, is it in the form y equals kx? That first one certainly looks like it is, because it is. It's y equals form, there's no plus a number, so there's no y-intercept. So this is direct variation. Your k value is the slope, it's the number in front of x. The k value is negative 4/3. All right, the second one, y equals 2x plus 4. Okay, again, is that in the form y equals kx? No, it's not. This is not direct variation because the y-intercept is not 0. Again, these are easy. Even though we do it after linear equations, it's actually easier. Okay, what about 3? 3 is not in the form y equals kx. Okay. Now, 2 wasn't in the form y equals kx either, but we couldn't make it into that form because of that y-intercept. 3 is not in the form, but we could make it into the form if we divide both sides by 2. So now we get y equals 5 halves, 5 over 2, x. And now that's in y equals kx form, which means this is still direct variation. Yes again. And your k value, again, it's not the number in front of x, it's the number in front of x when it's in that y equals kx form. So your k value is not 5, it's 5 halves. It has to be in that form. All right, and the last one, it's not in the form. Can we make it into the form? Maybe. We'll have to try. We'll have to get y by itself. So if you get y by itself, you'll have to subtract 2x over. 3y equals negative 2x plus 6. All right, and then when we divide by 3 to get y by itself, to put in either slope-intercept or direct variation form, you'll notice that the y-intercept doesn't go away. There is going to be a y-intercept there. It's a y-intercept of 2. So this one is no because of that y-intercept, so same reason. So it's pretty easy to identify direct variation if you're given the equation. And if it's not in standard and slope-intercept form, just solve for y and see if it is in that y equals kx form. If it is, direct variation. If it's not direct variation. The next representation we're going to look at is tables. How do we tell if we have direct variation in a table? Okay. There's still a special pattern that we're going to be looking for. Now, one thing that's always going to be true is that origin part, the y-intercept being 0. So if you have a table, which are a bunch of xy pairs, 0, 0 needs to be on the table. Now, 0, 0 might not be on the table explicitly, but if you could find a way to get to 0, 0, then it would be. It's still direct variation. Okay, so 0, 0 should be somewhere in the table. Maybe it's not written, but if the pattern were to continue, it would be one of the values. The other way to check direct variation is that ratio of y over x has to be the same. That k value, the constant of variation, is the ratio of y over x. So in your table, you have x values and you have y values. If you divide y divided by x, and it's the same term, the same factor each time, then that is direct variation. So if your k value, if your y over x ratio is constant, okay, throughout the entire table, then it is direct variation. So if it's constant, if it's a constant ratio, then it is direct variation. We'll say dv, direct variation. So if you don't have 0, 0, and you can't figure out if it's going to be in there or not, just start dividing the y values by their x values. If you get the same value each time, the same ratio each time, then it is going to be direct variation. So let's look at some examples given the tables. All right, number 5, that first table. It's looking good so far because 0, 0 is the first point. Okay, so we know it's going through the origin. Now that doesn't necessarily mean this is a linear table just because it goes through the origin, but we could check that by doing y divided by x. So start dividing some y's over x's. 3 over 1 is 3. 6 over 2 is 3. 9 over 3 is 3. 12 over 4 is 3. So all of these ratios, y divided by x, is 3. That's your k value. Your k value is y over x, and since it's constant, it is direct variation. So our y over x is 3 each time. In this problem, it said if yes, write the equation. Okay, this one is yes. So how do we write the equation? Well, it's easy. You just do y equals kx and plug in what k is. So y equals 3x. That's your direct variation equation. Okay. The next one, we got a bunch of values in here. So one thing you could do is you could start dividing y over x. The other thing is look if there's any zeros. And this one does have the y-intercept in it. It's in the middle this time. It's 0, 1. Remember, to be direct variation, it has to be a y-intercept of the origin, and y-intercept of 0, 0. So this one is automatically no because of that point. Now again, you could double check, do some y's divided by x's. 3 over negative 1 is negative 3. And then you got negative 1 over 1, which is negative 1. Right away, those aren't the same. They don't match. That ratio is not constant. It's not direct variation. Moving on to the next one. All right, the next table doesn't have a y-intercept in it. Okay. Now, if you can figure out what the pattern is, it's going up by 2's, and the y's are going up by 4's. So if you went down by 2 and down by 4, you'd end up with 0, 0 as the previous term. But again, there's other ways to do this. You could check for some y's over x's. Check that ratio of y over x. 4 over 2 is 2. You could try all of them. You could try some of them. Just figure out what the pattern is. 12 over 6 is also 2. 20 over 10, also 2. That ratio is staying constant throughout. So this one's yes. Your k value is 2. Y equals kx. Y equals 2x is the equation. Again, tables, also pretty easy. Make sure 0, 0 is in there. Check if the ratio is constant. If it's 0, 0 and it's a constant ratio, it is direct variation. If one of those is not true, it's not direct variation. Graphs are up next. That's the next representation. The graph of a direct variation function, again, same kind of pattern as all these other ones. It's going to be a line that goes through the origin. Again, it has to be linear, so it has to be a linear, straight line. It's a line that goes through the origin. It goes through 0, 0. If it doesn't go through 0, 0, it's not direct variation. Simple. The line can be positive or negative sloping. So again, our first definition was x increases, y increases, which implies it's always going to be positive. It's not, so it's positive or negative slopes, as long as it goes through the origin. And what would the k value be? The k value on a graph, your constant of variation, is just the slope. Okay, we know how to count the slope from a graph. Pick 2 points. How do you go from one point to the next point? And rise over run. So let's look at the graph examples. Determine if the following graphs represent direct variation. If yes, write the equation. So number 8, the first one. Does it go through the origin? Yes, it does. Okay, which means it is direct variation. So we'll have to find the k value if we want to write the equation. We're going to have to find the slope. So pick 2 points. To pick 2 nice points. The origin is one of them. Might as well pick it. And then this next one up here. How many do we go up and how many do we go over to get to the next point? We're going up 2, over 1, rise over run, slope of 2, which means you have a k value of 2. So m, which is your k value, is 2. So your equation would be y equals 2x. The next graph got a little strange in the conversion, but we can see that the origin's down here, and your graph is up here, and your graph is not going through that origin, which is automatic no, this is not direct variation. All right, in 10, we finally have a downward sloping line. Check the origin. Looks like the line is going through it. So this is yes. Find the slope. Again, you might as well pick the origin as one of your points. Pick a point further down the line. So we got one down here. And then count the slope. This one we are going to have to go down -2, down 2, right 1, 2, 3, down 2, right 3 is a slope or a k value of -2/3, which means we're going to have an equation of y equals negative 2/3 x. Next up is the verbal model. So what does this look like in words? In words, you're always going to have the specific phrase. You're always going to have the specific phrase of y varies directly with x. So y varies directly, so varies directly, direct variation. It's basically telling you that it's true. Y varies directly as x. You're always going to see that. If you're given a verbal model and you want to write the equation, there's going to be 2 steps. First, you have to find k. Find k, which is going to be doing y over x, same as the table. And then step 2 is write the equation. And then there's a couple other versions of this that we'll see in a second. And we'll write that down when we get to it. So in these first examples, we're going to write an equation. We're assuming that y varies directly as x. So we need to find the k value and then write the equation. So find k, we're given y equals 16 when x equals 4. K is y over x. So k equals y over x. Y is 16 when x is 4. 16 over 4. You have a k value of 4. Step 2, write the equation. You know what k is, plug it in, y equals kx. So y equals 4x. Again, these are easy. Do the same thing for the other 2. Find k by dividing y over x. So y is 1/2 when x is 12. So you're going to do 1/2 over 12. Okay. When you have a fraction over on top of a whole number, you actually multiply the denominator, the smaller denominator, by the bigger denominator. So this is 1 over 24. That's your k value. So your equation is y equals 1 over 24x. Same thing on the last one. Find the k value. Y is negative 1 when x is 2/5. Okay, so you're going to have to know some fraction skills for this one. When you have a whole number divided by a fraction, you can flip the denominator, multiply by the reciprocal. So this is going to be negative 5 halves. That's your k value. Write the equation. Y equals kx. Y equals negative 5 halves, 5 over 2. X. Again, very easy. Alright, so that was the first type of verbal model. A lot of problems with direct variation kind of go further. So the first 2 parts are the same. You want to find k, you want to find the equation, and then you're going to use that equation to answer a question. So a lot of problems you'll see are more often written like this. So in 15, suppose y varies directly as x. Okay, there's that phrase that has to be in all these. If y equals 10 when x equals 5, find y when x equals 7. Okay. First thing we're going to have to do is find k. Okay. We know that y varies directly as x because it says so. We know this is direct variation. So we're going to have to find k first by doing y over x for the full version that they gave us. So they gave us y equals 10 when x equals 5. So they gave us a point, basically. They gave us part of the table. So k is going to be y over x, 10 over 5, which is 2. We're going to use that k value to then write the equation. The equation y equals kx. We just found k. K is 2. We're going to use that in our equation y equals 2x. All right, and then we're going to use that equation to answer that final question. The final question is find y when x is 7. So plug in 7 for x and find y. So last step is to solve. Instead of y equals 2x, we're doing it when x equals 7, so y equals 2 times 7. Y equals 14. Now they gave us y, or they gave us x and wanted to find y. The next one is flipped. It's another direct variation, but this time we're finding x. So suppose y varies directly as x. If y equals 3, when x equals 2, find x when y equals 9. Start with k. Use the y they give you and the x they give you. Y over x, 3 over 2, is just 3 over 2, or 1.5. All right, write the equation. Y equals kx, y equals 3 halves x. Use the equation to solve the question. Find x when y is 9. So we're going to plug in 9 for y and solve for x. Now you could do this all in one step. You could do it in separate steps. All in one step would be 9 times 2/3. Separate steps, multiply both sides by 2 first to get rid of the fraction. Gives you 18 equals 3x. And then divide both sides by 3. So our direct variation, our x value, would be 6. So x is 6 when y is 9. Last up is a word problem. So direct variation word problem. Okay, so let's read this problem. A local fast food restaurant takes in $9,000 in a 4-hour period. Write a direct variation equation for the relationship between income and number of hours. Okay, so those are going to be our variables, our x and our y, or really our y and our x. Estimate how many hours it would take the restaurant to earn $20,250. Write a direct variation equation for the income in any number of hours worked. Okay, so our y value, our output, is income, and our x value would be hours. Well, for us to do this, they have to give us a full y and x. And they do in the first statement. First statement, they tell us that a restaurant takes in $9,000, that's an income, in a 4-hour period. That's an hours. So our y value is 9,000. Our x value is 4. We're going to use that to find k, because k is always y over x. 9,000 divided by 4 is 2250. That's your k value. Now again, that's not our answer. The problem said to write the equation. So you can't just find k, you have to write the equation. The equation is y equals kx, so the equation is y equals 2250x. Estimate how many hours it would take for the restaurant to earn $20,250. Okay. How many hours? Hours is x. So they're giving us y, they're giving us a money amount, and we have to solve for the hours amount. So we're just going to rewrite that equation, y equals 2,250x, but we're going to plug in 20,250 for y, and then solve for x. Now again, direct variation again is easy. These are just one-step equations. We don't have to add or subtract. You're always just going to divide the k value. So divide both sides by 2250. You get an x value of 9. So 9 hours for the restaurant to earn that much money, $20,250. All right, so that's all direct variation is. You know, it's a lot of little things, but you find k, you plug it into the equation. Okay, that's how you write the equation. If you're given a graph, a table, equation, you just have to make sure that it goes through the origin. Okay, make sure it has a y-intercept of 0. Okay. And that's it. Y equals kx. Figure out what k is. K is the constant ratio between y over x. Again, these are pretty easy.